Good evening and welcome. The purpose of the Young Israel Shomrei Emunah Meaningful Tefilah Project is to present programs helping all of us deepen our faith in Hashem and develop greater kavanah, intention in our davening. Since 2014, we have offered programs delving into the meaning of the Shema, Amidah, Hallel, Ashrei, Selichot, Vidui, and more, offered classes in Chazanut, and posted 40 videos of these programs on YouTube, some with more than 500 views. You can find them on the Meaningful Tefilah Project YouTube channel. Tonight is the second program in a year-long series intended to help us better appreciate the presence of Hashem in the world around us and in our daily lives. We welcome KMS as a sponsor of this series. Tonight's topic is the science behind Asher Yatzar, the most frequently recited bracha. I will introduce our speaker in a moment. Our first lecture last month by Dr. Jeremy Schnittman was about our vast universe. At our next lecture at 10:30 in the morning on Sunday, May 8th, Dr. John Gollin will focus us inward on submicroscopic processes found within all living beings. That will be followed by several lectures about periods or points in history where we can most clearly see the hand of Hashem shaping events, whether on behalf of the Jewish people in particular or for humanity in general. Those will be followed by yet another series of lectures and perhaps panel discussions, discussing times when individuals have perceived Hashem intervening in their lives in ways that have enhanced their personal faith and kavanah. If you would like to be reminded of upcoming programs and have not already done so, please send your email address to me at stuartrosenthal@yais.org. Sponsors are also welcome. I would like to thank our sponsors to date, Ken and Cheryl Jacobson, Mark and Debbie Katz, and Max and Debbie Rudman. We hope, as COVID recedes into the background in Mirza Hashem, to be able to return to in-person programming that, as in earlier times, will be followed by refreshments and socializing. We'll keep you informed. Please also tell your friends about this series and encourage them to join us. Our speaker tonight is Dr. Aaron Cypess. Aaron did his undergraduate training in chemistry at Princeton University, then completed his doctorate at Rockefeller University, and received his medical degree from Weill Cornell. He did his medical residency and endocrinology fellowship at Beth Israel Deaconess Medical Center in Boston. During his training, he also studied medical halacha at the Schlesinger Institute at Shaarei Tzedek Medical Center in Yerushalayim and learned at Yeshivat Har Etzion. Dr. Cypess was an assistant professor of medicine at Harvard Medical School prior to moving to Silver Spring with his family 8 years ago to work at NIH. He currently runs a clinical program studying clinical research program studying human brown and white fat and treats inpatients who have diabetes and obesity at the NIH Clinical Center. In addition to giving lectures in the community about medicine, science, and Torah, Aaron enjoys reading his wife Leah's books and going on hikes and bike rides with his family. If you have questions for Aaron as he speaks, please type them in the chat window, and we will address as many of them as time permits when he has completed his remarks. My wife Judy will be collecting the questions and presenting them to Aaron at that time. Speaking of which, given the number of fascinating questions at our last session, we are prepared to extend tonight's program till 9:15 if needed. Of course, you're welcome to leave at any time. Tonight's program is being taped and will be posted on the Meaningful Tefilah Project channel on YouTube, so you may watch it again at any time. Before Aaron speaks, I would like to invite Rabbi Yosef Pastelnik to share some words of Torah. For those of you who haven't yet had the pleasure of meeting him, Rabbi Pastelnik became assistant rabbi at Young Israel Shomrei Emunah this past fall. He grew up in the Fairfax, Virginia Jewish community and is an Eagle Scout. He has a bachelor's degree in Smicha from Yeshiva University. Rabbi Pastelnik and his wife Eliza and their children have been a wonderful addition to our shul and to our community. After the rabbi speaks, Aaron will begin his presentation. We thank you both for your participation tonight. Rabbi Pastelnik, the floor is yours.
Thank you so much, Stuart, Rabbi Rosenbaum, everyone involved. Thanks for the opportunity to introduce this beautiful topic. It looks very nice, and I'm excited to hear it myself. It reminded me of a pasuk in Eov, Mibsari echse Eloka, that through my flesh, through my body, I can witness God. So classically that pasuk, that line, that verse means that Hashem created us as microcosms of the universe, which essentially gives us a lens to be able to observe Hashem, the way he interacts with us in the world, the different manifestations of Hashem's attributes. But on a more basic level, Mibsari echse Elokai, the idea that from my flesh, from my body, I can witness Hashem. What it really means is that I can look at nature, I can look at the human physiology, and I can look at myself And from there, I can find Hashem in life. So the word that's used in the verse is the name of Hashem Elohim. So usually that name of Hashem means that Hashem's hidden a little behind nature, that Hashem interacts with us through very natural ways. And so a person who's not noticing the world around him, a person who's not looking to find Hashem, could very easily sit there and say, the world is devoid of the divine. Hashem's not running it. But if a person just takes a minute to look around us, to take a look at ourselves, so we'll be struck by the idea that there's Hashem running the world. I saw that Rav Simcha Zissel, the Alter of Kelm, says that if a person wants to find and connect to Hashem, so all he has to do is look at the world around him, ubi yoser, even more so, mimenu uminafsho. If he looks at his own self, if he looks at his own soul, his own being, from there he's going to be able to find Hashem. So there are a lot of places where we can find Hashem. There's the shul. We can find Hashem in spiritual avenues. We can find Hashem in wondrous places like the Grand Canyon. But most of all, we can find Hashem in our own bodies. And so I think this is a wonderful, beautiful opportunity to be able to learn more about our bodies, more about our physiology, in a way that we can take a step back and just take a moment to be able to focus and say, wow, there's a being, there's Hashem running the world, and behind all the Hester, behind all the hiddenness in life, behind all those moments where I'm not sure, I just don't see Hashem. So we can take a step back and be able to say, wow, Hashem's here, Hashem's running our life. And it's really an opportunity to be able to connect and to be able to see that. So Mirza Hashem, we should all be zocha to be able to do that and learn more through this wonderful presentation. Thank you.
Aaron, go right ahead. It's all yours.
All right. Thank you. Thank you, Rabbi Postelnik, for those great introductory words. And I would also like to begin by thanking all the organizers of this outstanding lecture series for inviting me tonight to give this talk. I hope that it becomes the beginning of many long-term discussions and amplifications of the material presented tonight. Yes, the science behind Asher Yatzar, the most frequently recited bracha, and I know you might say, there might be others that are more frequently cited by certain people. It's certainly in the top 5, and for many of us, it's number 1. So I'm going to begin by giving an outline of our discussion, and I'm going to introduce it in the classic Talmudic way through questions. I'm not going to give the answers right now, but there should be points of discussion and thought in your mind. First, the topology of the human body is most similar to what object? A sphere, a torus, a double torus, or a Klein bottle. Number 2, how many cells are there in the human body? 1 million, 10 to the 6th, 1 billion, 1 trillion, or 1 quadrillion, that's 10 to the 15th cells. Number 3, true or false? There are more bacterial cells than human cells in and on our bodies. Number 4, true or false? To reduce the risk of getting food allergies, one should avoid washing hands with soap and water before eating. Number 5, what is a fractal? Is it a type of Muppet that lives on a rock? For those of you from Gen X, you'll know what I'm talking about. Is a fractal a cousin of the pterodactyl? Is it a small bone fracture? Or is it a curve or object that exists in between classical Euclidean dimensions? And the last question, when added up, how long are the blood vessels in a person? Do they add up to being 20 feet, 100 feet, 10 miles, or 60,000 miles? You'll know the answers to all of these questions and more by the end of this talk. Okay, so let's begin with the bracha itself, and the original discussion really is in brachot 60b. Baruch atah Hashem Elokeinu melech haolam, asher yetzav et ha'adam b'chokhmah, v'varavo nekavim nekavim, chalulim chalulim. Blessed are you, Hashem, our God, sovereign of the universe, who formed humans with wisdom and created within them many openings, the nekavim, and many hollows or tubes, chalulim. Well, galui v'yodua b'fnei chisei chivodecha, she'im yibatech echad mehem, u'yisatem echad mehem, yefshar litkayem lamo lefanecha. It is obvious in the presence of your glorious throne that if one of them were ruptured, or if one of them were blocked, it will be impossible to exist and stand in your presence. Baruch atah Hashem, Blessed are you, Hashem, who heals all flesh and performs wonders. So let's begin with an introduction to topology. Now, I'm going to go through some potentially esoteric concepts. They are for interest if you have it. We do not have to go into any great detail, and you don't have to understand the fine details to appreciate what I'd like to talk about this evening. So in mathematics, topology, it comes from the Greek words topos, meaning a place or location, and logos, meaning study. And topology is concerned with the properties of a geometric object that are preserved under continuous deformations, such as stretching, twisting, crumpling, and bending. That is, without closing holes, opening holes, tearing, gluing, or passing through itself. And you can see here an example. This is a coffee mug, or is it a donut? Or is it a coffee mug? So it turns out that they have the same topological qualities because none of these rules have been violated. So the common topological items that we think about will be a sphere, a solid ball, for example, a torus, or a bagel, or a donut, or an inner tube, depending on what you like, a double torus, which has 2 holes, a cross surface, which is this entity here, and then the Klein bottle, which is a very strange concept. It is essentially a 3-dimensional version of the Mobius strip. And I'm not going to go any more great detail than that, but it's a really funky thing to look up if you're interested. All right, nikavim nakavim, the openings in the body and the topology of the human body. And so overall, the key point is that we are not holy balls, but spongy donuts. In other words, we're not spheres, but we're toruses. And I'll show you why here in this diagram. So here's a person, and the mouth is over here. Food would go down the esophagus, down into the stomach, through the tortuous 30 feet of the small intestine, eventually into the large intestine, which is also known as the colon, and then eventually out the rectum and the anus. And this whole series of tubes is called the GI tract. So the first thing is that our mouth through the anus is not even a nekev so much as it is a chalul. And if you can see here in this diagram on the right, here's the mouth, stomach, intestine, and anus. It is a hole or a tube within a larger body. Now there are nikavim in our body, those openings. So for example, there are sweat glands, which are microscopic, but they're there. The lung is another such opening. The liver and the pancreas, they're tubes that release digestive bile, for example, from the liver, and digestive enzymes from the pancreas. Those are released into the larger central tube that goes from mouth to anus. The kidney, in other words, the urine production, the reproductive tract, these are nikavim that open to separate openings outside of the body. So it's important to appreciate. Yeah.
So I got a note saying that some people aren't seeing the slides. Is that true? Are there people who cannot see the shared screen?
The slides are there. I suggest anyone who's having trouble, look for a view button, usually in the corner of your screen, and there are several different settings, and you want something like side-by-side speaker is what you want to see.
Thank you. Please carry on, Aaron. I'm sorry about the interruption.
Right, so it's not on my end, correct? Okay. All right, we'll continue. So the topology of the human body is essentially a torus, or more importantly, a donut. You can see here the donut with the hole through the center, going from one end to the other. And our body, all the stuff that's inside of us, is in this region here. Now note the spaces that's in a donut. That's also in us. We'll go into it. I chose a donut for a number of reasons, one of which is that if you look at Shemot, Tet Zayin Lamed Aleph, the description of man, according to my brother, Rabbi Joshua Cypess, really could very well be donuts. So I think there's a very Kedusha level to a donut that rises above all other toruses, which is why I compare the human body, one of the pinnacles of creation, to donuts in terms of topology. Okay, so now we get to the number of cells in the human body. And the human cells, and there are different measurements, and you'll see different numbers, but essentially within an order of magnitude, there are 30 trillion cells. And I cited a paper here by Ron Milo and his colleagues from the Weizmann Institute, because, hey, let's give some credit to our colleagues in Israel. So there's roughly 30 trillion cells, and they're dominated by the red blood cells in our blood. If you look at the proportion of cells just by number, erythrocytes, that's red blood cells. Erythro is red in Greek, cytes is cells in Greek. 84% of our cells are red blood cells. and a number of them, about 5%, are platelets. Those are the smaller cells we'll learn about that help clot blood. My favorite cell type, the fat cells, are adipocytes. It's almost 0.2%. And as you can see, most of the other cells in the body are somewhere between 0.01, 0.01 to maybe a little over 2%. So most of the cells in our body are red blood cells. Now, how many bacterial cells are in and on our body? The colon itself has roughly 40 trillion, and that may be roughly the number we're talking about. So you want to talk about bacterial cells versus human cells. There are more bacterial cells in a human than there are human cells in a human. So I was thinking when it says in Breshit, Na'aseh Adam b'Salmenu kidmutenu, you wonder if HaKadosh Baruch Hu was speaking to the bacteria and saying, let's put something together. That's just one possible later day midrash to think about what's going on there. In any case, so what are we? Are we a massive bacteria controlling a humanoid? Are we humans engaging in a massive effort of nasat orchim? Well, let's look about it, not just by number, but by size. And you can see here from that same paper that if you have 30 trillion cells, 25 trillion are red blood cells and 5% of the rest of the body, and then there's 38 trillion bacterial cells, certainly by number, bacteria outnumber humans. But in terms of actual mass, it's a different story. You can see here that the 25 trillion blood cells, that's only about 3 kilograms, roughly 7 pounds, and that most of our mass is muscle cells, other like for example, bones. 13% are adipocytes, that's fat cells, although in some people that's a far higher amount of mass in our bodies. And the bacteria are roughly 200 grams, so not very much. So to answer the question, who are we? We're really humans engaging in a massive effort of achnasat orchim. Okay, now the number of cells in the body, human and bacterial, is influenced by the topology that I just showed you, which is why it's very important. And it's enabled by our immune systems. So for example, the trillions of bacteria are either on our skin or in our gut or gastrointestinal or GI tract. Both of these locations, the skin and the GI tract, are topologically outside our body. So when you think of your kishkas or your inside, the deepest inside your body is topologically outside. What that does is that allows us to have a relationship with these bacteria, which are known as the microbiome, micro meaning very small, bio meaning living organisms. So how are we protected from all these bacteria? The simple answer is the immune system that is inside your body and the bacteria are outside your body, and the skin and the gut have physical barriers and also specific cells that are devoted to a very robust immune response that's different from anywhere else in the body. And just as an example, here's a diagram of the GI tract. Here's the mouth, and then here's the stomach, small intestine, and colon. And the stomach has a very low pH. It is very acidic, as many of you well know from personal experience. And there's a lot of oxygen in the stomach, which you also possibly know from personal experience. There's not that many bacteria in the stomach, but if the bacteria can get through to the duodenum, that's the first part of the small intestine, and it's duodenum if you're a surgeon. You just have to know who you're talking to as to how to pronounce the word. And then there's the colon. By the time you get to the colon, it's neutral pH, so it's not acidic or basic. It's pretty comfortable, as it were. Not much oxygen. There's mucus, and there's host indigestible polysaccharides. In other words, when you eat fiber, that fiber, which your body can't digest, is delicious for the microbiome bacteria that live, the Firmicutes, the Bacteroidetes. Those are the ones that predominate. There's a high diversity, which I'll show you a little bit about, and that's where our major bacterial load is. So that's how we do it, and that's why the topology matters. Now, let's go into the people in your neighborhood, and I think here's Bob, who sang that song that I remember from when I was a kid. Another Gen X shout out there. The normal bacterial flora in a normal person who lives in the community, and I'll tell you what that means. That's in contrast to someone who is in the hospital, for example. Their upper respiratory tract has a certain milieu that supports different kinds of staph, different kinds of strep, Haemophilus and anaerobic bacteria. The skin has a different kind of staph and other bacteria. The gastrointestinal tract, again, has a lot of anaerobes, also Enterococcus and a number of other bacteria and some fungus. And the genital tract has lactobacillus, some streptococcus also. These are all normal bacteria that are happy being there and don't cause you any harm under normal circumstances. Now, what determines the composition of the gut microbiome? It can change. One of the big factors is diet and lifestyle. You can alter your microbiome. Obviously, infection, introduction of something like Shigella, that'll change what's in there. Drugs, antibiotics, those will change the bacteria. For example, taking something like clindamycin will suppress some of the healthy normal bacteria that's in your body and allow Clostridium difficile to grow. Genetics will determine it, age will determine it, host, environment, and geography. There are different bacteria in different soils and different parts of our bodies. Okay, so we have been designed very cleverly, spanning 1 billion years of immune system to development to allow this symbiosis between the microbiome and humans based on our topology. So what comes first is the innate immunity. That's been around for a while, and that is against foreign bodies, injuries, and pathogens. And these include bacteria-killing substances in our saliva, in our eyes, and then, as we mentioned, the acid in the stomach. Those are very important for protecting us from the wrong bacteria from getting in. We have our mucous membranes, which are a lot of defenses, and then there are some scavenger cells. Then a more sophisticated process is the adaptive immune system here on the left. And these go against specific pathogens or changed body cells, such as cancer cells. And so defense cells in the blood include the B lymphocytes. They make antibodies. And then there's also in the tissue the T lymphocytes. And I imagine that everybody here is far more cognizant of B cells, antibodies, and T cells in response to thinking about the COVID-19 pandemic. Now, these things have been with us for many hundreds of millions of years. So going back 700 millions of years ago, that's when the origin of innate immunity was seen in animals. Eventually, the adaptive immunity, the more sophisticated one, came when there was the development of the jawed vertebrates. And that's been with us for several hundred million years. That means that this process has been refined, evolved, and works very well, and is therefore not going to respond so well to certain kinds of jarring changes that have occurred only in the last 50 to 70 years. For example, the bacterial flora in a normal person who is in a hospital or is in a long-term care facility, the microbiome will change. The upper respiratory tract will get, yes, the normal staph, but will also get new kinds of bacteria, such as E. coli and Klebsiella. They're supposed to be in the gut. They should not be in the upper respiratory tract. Or on the skin, you can get E. coli and Klebsiella. In the gastrointestinal tract, Pseudomonas, among many others, and then Candida in the genital tract. So what happens is a number of interventions lead to the wrong bacteria being in our bodies, and that is not helpful. And this is I like the diagram. I don't think all the details here have necessarily been established convincingly, but you can see here in the faded colors, the pink and the green. Pink and red are disease-related. Green, light green, and darker green are health-related. But for example, proton pump inhibitors, those can, such as antibiotics, can affect the type of bacteria that are in our body, can make it not so good. Certain kinds of fatty acids that we eat, glucose and fructose in certain kinds, excessive protein consumption, altered pH. These can all lead to changes, and we won't go through all the details right now, but they can lead to things as unexpected as insulin resistance, increased frequency of diarrhea, lipopolysaccharide production. But on the other side, the right kind of diet, such as having fiber intake, the right kinds of probiotics in your food, that can lead to beneficial changes. So this is an active, dynamic process that we can alter. What's the best thing to do? That's still being determined. I wanted to take just a moment because I hear about this when I travel to the New York City metropolitan area sometimes, about the hygiene hypothesis. And I wanted to mention as it relates to the healthy microbiome. Now, there's been this observation, this is published in the Proceedings of the National Academy of Sciences, that since the 1950s, rates of autoimmune diseases and other kinds of immune dysfunction, such as multiple sclerosis, Crohn's disease, type 1 diabetes, and asthma, have soared by more than 300%. And you can see similar graphs depicting concurrent spikes in hay fever and food allergies. Now, mirroring this alarming surge in autoimmune and allergic disorders are simultaneous sharp declines in the incidence of mumps, measles, tuberculosis, and other infectious diseases in developed countries, thanks to the advent of vaccines and antibiotics, and to improved hygiene. Perhaps the reduction in infections was causing human immune systems to malfunction in some way, and this is all connected. So this would be the hygiene hypothesis. Now, Grambrook and countless others within the field have remarked about this hygiene hypothesis and said that we know an awful lot now about why our immune system's regulation is not in terribly good shape. And it's got absolutely nothing to do with hygiene. Rather, it is thought now that early exposure to a diverse range of the friendly microbes, the microbiome that's been our friends and that's been in our gut and on our skin for the last several million years of human evolution and hundreds of millions of years of mammalian evolution. It's those friendly microbes that aren't there anymore, not the infectious pathogens. And that is what's necessary to train the immune system to react appropriately to stimuli. And I'm not going to go into great detail now, but your immune system is incredible. It has to recognize self and also not overreact it has to recognize self and not kill it, and at the same time recognize not self and get rid of it from the body. And so it's thought that having a healthy microbiome might possibly reverse some aspects of the rise in autoimmune diseases and asthma and other reactions that we're seeing today. Again, this is a complicated topic, but this is very important. All right. So as it says in the bracha, Shemi batech echad mehem. What happens if one of these openings is opened? So you'll have a violation of the topology. And you can see here what happens if these openings get open. And as you can imagine, it's not good. For example, if there is an opening in the skin of the GI tract, the bacteria and the fungi, and remember, there's a lot of them there, they can get in and cause local or systemic infections, such as a Staph aureus abscess or P. acnes. In other words, acne is related to that. Strep pyogenes causing rheumatic fever. All of these nikavim can get infected. In the lung, as we know, there's COVID-19 or strep pneumonia. That can be a problem. The kidney, you can get an E. coli pyelonephritis. You have a visitor. This is not the right kind of oreach when something from this region gets up into this region. And in the reproductive area, chlamydia can cause pelvic inflammatory disease and cause an opening in the wrong place in the reproductive tract. And if there's a structural violation, that's a hernia. And for example, where is a hernia? That is where one part of the body goes into a different part of the body, a violation of the topology. So you'll have a stomach that is below the diaphragm. So we have our chest, and our lungs and heart are in our chest. The diaphragm is a large muscle that separates the chest or thorax from the abdomen. And the esophagus, though, that has to get all the way from the thorax into the abdomen. So there is a hole that is designed to be there, and that is called a hiatus. The esophageal hiatus then goes to the stomach. Well, what happens if the esophageal hiatus, the stomach goes into it? Well, that's called a sliding hiatal hernia. And if it gets stuck there, that's even worse. So hernias are where things are going and violating the topology. You can have the hiatal hernia, as we just talked about. There's an inguinal hernia, and I tested that experience out twice, where the intestines go through the muscle where they're not supposed to be and get into regions where it's a problem. And there can also be abdominal hernias where there's a weakness, and particularly in people with a lot of obesity, where there can be an umbilical hernia, where the abdominal contents leave the center of the body and go out. So it's a real problem if im yapatech echad mehem. And so with that, talking about nikavim, the openings, I want to now move on to the chalulim, which are the hollows or the tubes of the body. So we'll talk about that in relation to the most important tubes, I think, which are the blood vessels, or more technically, the vasculature. Now, the circulatory system is a marvel of design. And we're going to go back to some topology. Remember, we are a donut. You've got our mouth here. This is the gastrointestinal tract, and this is the anus. And this blue area here is the body. But there is this red tube within a tube, and that holds the blood vessels. Now, for the longest period of time, people did not believe that the blood was in a circulatory system, but that it was made and it was destroyed on a regular basis. And it was William Harvey. I had the opportunity, thanks to my father's recommendation, of taking this course by Professor Michael Mahoney, Princeton freshman year. And it was Science and Human Affairs, class 291. It's a tough course. I read De Motu Cordis, which is Harvey's original work, which was published in 1628. But if you want to hear Jeremy Brown's discussion of it through the Talmudology website, it's Rosh Hashanah 22a. And so he determined that the circulatory system was a closed system. Now, there are three types of tubes within the structure. There are arteries, shown here, and they're usually pictured as red because they carry oxygenated blood away from the heart. And so arteries have a big wall with a lot of muscle, and then here's the actual surface. Then there are capillaries. Those are the single cell thick tubes that feed most of the body. And then there are the veins, which can be larger, but they have less muscle, and they have valves to make sure the blood always goes in one direction back to the heart. The components within the blood vessels are plasma, which is the liquid portion, the red blood cells, which we talked about, which are here, and they carry the oxygen. There are white blood cells, which are essentially responsible for protecting us from invaders. And then there are the platelets, which are these small entities, smaller than the red blood cells, and they're responsible for blood clotting. Now, what are the jobs of the blood vessels, meaning the vasculature? So what are the physiological roles? What do they do in our bodies? Well, the most important one is to deliver oxygen and remove carbon dioxide from every cell. The vasculature is also important for transporting nutrients, carbohydrates, fats, and proteins, which are the three main nutrients. I've often wondered why there are just 3 and not 4 or 6 or whatever. It's interesting how we're designed. Now, the blood is also very important for allowing the sending of messages between organs. And the study of this message sending is endocrinology. So shout out to my field. Now, the blood also carries cells and antibodies that fight infection. They bring waste products to the kidneys and the liver, and those organs filter and clean the blood. The blood actually helps regulate body temperature, which is really important for those of us, for example, who daven outside on occasion. And the blood is also necessary for forming blood clots to prevent excess blood loss. So there's a lot of things that the blood and the vasculature do. Now, the problem is that we need to find a way to maximize function with limited material. And I'll tell you what the challenge is right here. The biggest challenge for your vasculature is that no cell of your trillion cells in your body can be more than 100 microns from a blood vessel. Otherwise, the oxygen can't get there and get out to support life. Remember, in CPR, you've got the A, B, C's, airway, breathing, circulation. Although, when you take CPR, you'll know it's become CAB. But the ABCs is the way to remember it. Oxygen is essential for life, and it's the thing that is lost first when life becomes at risk. Now, the paradox is that every cell needs to be near a blood vessel, but the body just can't be a bag of blood, which is kind of what insects are. So here's a scale model, for example. Here's something that's 1,000 microns. That's the thickness of a dime. This is what a table salt molecule entity looks like. This is 500 microns. And here's the human hair. Its width is 100 microns. So you have to have a blood vessel within 100 microns of every cell of the body. How do we do that? And just to add more challenge to the process, take a 70 kilogram human, that's a 154 pound adult. We have 5 liters of blood. That's 5.45 quarts. That's about 7% of the body weight. And we start with one large artery coming out of the heart. That's the aorta. And it branches to smaller capillaries, and then it reverses with the veins. So we start with one blood vessel, the aorta. It's 3 square centimeters in surface area. Capillaries of about 900 square centimeters in surface area. And then back to the vena cava. That's about 18 square centimeters. How long is the aorta? It's about 30 centimeters or 1 foot. How long is the main vein, the vena cava? It's about 22 centimeters or 3/4 of a foot. What is the total length of the capillaries in the body? 60,000 miles. How do you fit 60,000 miles of blood vessels and yet still have blood, have like a heart and bones? How does that work? Well, fractals. Let's go into that. So we're going to maximize function with limited resources using something called fractals, and I'm going to talk about it It's going to have some concepts and it's going to make your mind very uncomfortable potentially, but in a good way. And a lot of this came about because of a very inspired Litvak named Benoit Mandelbrot. His family was, they were Lithuanian Jews who were living in Warsaw. They left Warsaw to go to France. And during the Shoah, Benoit Mandelbrot managed to survive in the French countryside. He then stayed in France, but then went to work for IBM in Yorktown Heights in New York. And that's where he made his major discoveries for fractals. If you want to talk about Jewish pride, there is a lot of, for example, Mitch Feigenbaum was another person who was very instrumental in the development of the fractal mathematics and sciences. So what's a fractal? A fractal is a never-ending pattern. I'll show you what these are. They're infinitely complex patterns that are self-similar across different scales. I'll show you about that. It's really amazing. They're created by us repeating a simple process over and over in an ongoing feedback loop. And that's what makes it possible to be in nature, because it's not that complicated in terms of the instructions. Although we don't know what many of the instructions are, they don't seem to be that complicated. They're driven by recursion, and fractals are images of dynamic systems, the pictures of chaos, not the Jurassic Park form of chaos. That's wrong, though entertaining. This is what real chaos is about, as I'll show you. Now, geometrically, fractals exist in between our familiar dimensions. Fractal patterns, in fact, are extremely familiar, since nature is full of fractals. Trees, rivers, coastlines, mountains, clouds, seashells, even hurricanes, their geometry is fractal, not standard Euclidean, as I will show you. And then abstract fractals, such as the Mandelbrot set, can be generated by a computer that can do calculations, a simple equation over and over again. I'll show you what that is now. So take this equation, z to the n plus 1 equals z to the n squared plus c. Don't worry about that, exactly what it means. You can find out more about it in this wonderful book that my parents got me back in the mid-'80s called Chaos. It's been through multiple printings by James Glick. This may be familiar to you. This is a Mandelbrot set, and it's generated by this equation here. You can see this at a particular scale, and I'm going to show you what happens when you zoom in through a Mandelbrot set. Watch. We'll keep zooming in, and you'll see that eventually we're going to run into, here it is, coming up, another Mandelbrot set. It just keeps going forever. We've now zoomed in by several 100 million orders of magnitude, and there it is again. So that's what's amazing about these kinds of features, that you just can keep zooming in over and over again. It'll be the same way again. There it is. Okay. Now, what in nature has a fractal quality? Well, you may know this, but the snowflake does. The snowflake is a fractal. It's not one-dimensional, two-dimensional. It's actually somewhere in between, as I'll show you. A tree. I took this picture on one of my bike rides. This is near the beginning of the Matthew Henson Trail, just north of Randolph Road in Dewey. It's a lovely trail, by the way. Matthew Henson Trail, great biking trail, incredible boardwalk. Okay, but the tree's also got a fractal dimension. These are the blood vessels of the human eye. This is the retina. These are the air sacs in a human lung. These are the blood vessels around those air sacs. Those have a fractal quality. And this are the foldings of the cristae, and I'll show you what those are in a mitochondrion. This is a scanning electron microscopic image. Okay, so we have to understand classical geometry to get there. So a point has 0 dimensions. A line has 1 dimension. A square or a triangle or a circle has 2 dimensions. A cube has 3 dimensions. We should be comfortable with this. Now we go to fractional dimensions. But before we do that, we have to understand, we have to have some terminology. And this you don't have to worry about understanding it completely, but basically there's n for a shape. That's the total number of unit objects. So n equals 1 here, n equals 4 here, n equals 9 here. R is the magnification factor. Here R is 1, here R is 2, here R is 3, and D is the dimension. So this is 1 dimension, here's a line, 2 dimensions is a square, and 3 dimensions is a cube. The way to find out what the dimension of an object is, D, is the log of n divided by the log of r. Again, trust me, you can look it up. We're going to use this to go on to the next step. Let's look at something called the Koch snowflake as a model for fractals in humans. So you take, I like this for a number of reasons, as I'll show you. So you take a triangle. That's easy. Now, what you're going to do in this triangle is each side, you're going to take the middle third segment of each side and make a mini triangle in it. and you'll remove the one that's connecting it. So you go from a triangle to a Magen David. So there you go. We're in here as Jewish people. Do it again and again and again, and you're going to find something fascinating. I'll show you what happens. So when you have that first line here, this is the first order and has a length of 1. So this side here is a length of 1, length of 1, length of 1. This is a length of 3. The first step, you make this little mini triangle here. The length of this side has gone from 1 to 4/3. I did the math with my son David as we were taking a walk on Shabbos. Do it again, and the length has gone from 1, then to 4/3 to 16/9, and then to 64/27. What happens is that eventually you'll get this snowflake, and if you blow it up, it doesn't matter. It's always going to look the same. There's a self-similarity to the Koch snowflake over every order of magnitude. This is what becomes discomforting yet fascinating. The Koch snowflake has an infinite length because the total length of the curve increases by a factor of 4/3 with each iteration. But the area surrounded by the Koch snowflake is only 8/5 times the area of the original triangle over here. So from here, this has an area. This area is 8/5 times that. And its fractal dimension, this would be, for example, but each line would be 1 dimension. The Koch snowflake has a dimension of not 1, which is a line, and not 2, which would be a filled triangle, but 1.26. That's its dimension. Most importantly, you have a shape that has an infinite length and a finite surface area. Uncomfortable? Well, guess what? It's working on you right now, because the mitochondria in your body, they're in each cell, and what they do is the mitochondria is it's a bacterium that got into a cell and then formed a symbiotic relationship. So you know how we have trillions of bacteria on our skin and in our gut? Well, these are bacteria that are inside our cells. Those are the mitochondria. We love mitochondria. And they have these folds called cristae, and it's in the cristae of the cells that is where the heat is being generated and energy is created. And so this is a figure from a paper that I was fortunate to publish recently in the New England Journal of Medicine. You can look it up. There's details here. And so the more folds in the cristae you have, the more energy the cell can generate for the functioning of the body. Well, how do you have as many folds as possible? Well, yeah, look at this. You can fold an enormous amount if you take advantage of fractal geometry. This is a figure shown by Saverio Cinti, who's one of the world authorities on brown adipose tissue, brown fat mitochondria and cells. He's in Ancona in Italy. And this is from a graphical abstract from a paper we published a few years ago where we study a drug called mirabegron. It activates brown fat. This is the graphical abstract. You don't have to worry about it. There's a reference here. But I just wanted to show everybody that I've loved fractals so much that when I showed this picture of brown fat, if you blow it up carefully, you'll see that I put in 2 Koch snowflakes to represent the folding mitochondria of the folding cristae in the mitochondria. So a little sneaky in there of fractals into the paper that was published. And I thanked my math teacher from high school, Dave Bach, who taught us about these fractals. All right. So it's not just the mitochondria. It's not just an abstract idea. Fractal design is very important for our brain and our lungs. Take a piece of paper, for example. It has a dimension essentially of 2. Yes, it has a little bit of thickness, but we can ignore that for now. It has a width and a length, and it's 8.5 by 11 in this case. Great. So the dimension of this sheet of paper is 2. Take that piece of paper and crumple it up. I do this and the kids love it. All right, what happens when you crumple a piece of paper? Well, it doesn't have a dimension of 2 anymore because it's got some sort of volume to it. But it's not a full piece of paper. It's not one ball of paper. It's not a sphere. It's something in between. It has a fractal dimension of 2.5. What else crumples like that to maximize surface area? Your brain. Your brain has a fractal dimension of roughly 2.6. And that's how you get 100 billion neurons in a brain and 1,000 trillion or 1 quadrillion estimated connections among those cells in your brain. That is very impressive. And it's possible because of the special folding that's done by the brain. And as it turns out, when there is pathology that happens, the fractal dimension of the brain goes down. It has fewer folds. It also happens within the lungs. This is a tennis court. It has a dimension of 2, has a width and a length. Now, the surface area of a tennis court is 160 square meters, or roughly 750 square feet. Now, take that tennis court and put a very thin layer, 1 cell thick, on it, just like that. That is the surface area of your lungs. But what you're going to do is you're going to take that tennis court size surface area and you're going to fold it ever so carefully so that it fits inside your chest. That folding is so intricate that the dimension of the alveoli, the air spaces within your lung, is 2.88. It's close to 3. It is almost so that every single cut in your lungs has gas exchange surface in it, and all the blood vessels have to go around it. To put it in perspective, if your lungs were merely balloons, they'd hold 6 liters of gas. That's about 1.5 gallons. And they'd have about 0.016 square meters of surface area. But because of the fractal folding of the lung cells, you have 10,000 times the surface area as if your lungs were balloons. And that means you can get oxygen into your body much more effectively. You can get the carbon dioxide out. Wow. Okay. So now, how do you fill a finite body with a near infinite mileage of blood vessels? Well, we go to the Menger sponge. Karl Menger, although he didn't identify as Jewish, his mother was Jewish, so we're going to claim him. He had to flee Nazi-occupied Austria. And the Menger sponge, I think, and I haven't seen this published anywhere, so this may be the first presentation of this analogy, and that'd be great if it happens in this series. The Menger sponge, you begin with a cube. That's 3 dimensions. Here, A. Then you divide every side of the cube into 9 smaller cubes, like a Rubik's Cube. You can see that here. This subdivides the entire cube into 27 smaller cubes, a Rubik's Cube. Now, the trick is to make a Menger sponge. You remove the smaller cube in the middle of each face. So here's B, you remove the middle one. So there's the middle and you've got the rest, the 8 cubes around it. And then you do that on each side and you remove the center cube as well. So hopefully you can see how you got 1 through 8 on this side, and then it'll be 8 on the other side to overlap. You eventually get 20 cubes among these 27, and you have 7 spaces. This is a level 1 Menger sponge. 20 cubes, 3 blocks per side. What does that mean? Well, you keep repeating it, C and then D, and you get a sense that something funky is going on here. The sponge's Hausdorff dimension, log of n over the log of r, n is 20, r is 3, is 2.73. All right, that means something. This is the implication. The Menger sponge volume approaches 0, while its surface area increases to infinity. And so too with the human body. Think of blood vessels as those holes, the chalulim, and the surface area is the ability to contact the trillion cells that are in us. So I'll give an example of what that would mean. This is a heart. And we think of hearts as being these muscles. Yes, there's a big cavity, but think about heart muscle. It's all muscle, but it needs to have blood vessels to survive. You need a lot of blood flow to the heart to keep it pumping. So this is the heart, and this is the blood vessels within the heart. So your heart, just like the rest of your body, is this incredible Menger sponge. And that's how it happens. So, or if one of them were blocked, it would be impossible to exist and stand in your presence. I think you get the idea right now, but let's think about it. You block a pulmonary airway, choking, pneumonia, pulmonary edema, big problem. Coronary arteries, if they get blocked, it's a heart attack. Once again, please learn CPR. Courses all over the place, including YSE. Cerebral vessels, if they're blocked, they lead to a stroke. Please learn how to identify a stroke in somebody. Time is brain. The GI tract, well, you can get constipation, that's not comfortable, or obstruction, which is a bigger problem. Kidneys, they can get kidney stones, very painful. Gallbladder, if it's blocked, then you get the back of a bile into the body, and that can cause jaundice. Reproduction, if there's blockage of the tubes, then there's infertility. And so I've kind of wondered, why is it that we say Asher Yatzar only after urination and defecation? I mean, why not say Asher Yatzar after a cardiac catheterization that unblocks a heart vessel? Or quite honestly, why not say it after you sneeze? You're demonstrating that the tubes and the openings are all open. That's a question for the rabbis. I think it's an interesting question. All right. There is repair and cell turnover to happening perpetually, and this is how we survive the blocking of any of these or the opening of any of these. It just shows you the lifespan of cells, and this is the total cellular mass. You can see here erythrocytes, they last about 120 days, and there is roughly 1 kilo to 2 kilos of them. The adipocytes, there's more, and you can just see there's a general relationship. The longer lived the cell, more mass there is of them. And if you look at it in our body, the total mass turnover rate is roughly 80 grams per day, and 41% of the cells that turn over are the gastrointestinal epithelial cells. Your body is constantly turning over the cells in your gut, and that's a good thing, but it can be problematic in the setting of chemotherapy. You can see that there are a lot of red blood cells. 1/4 of the cells that turn over every day are red blood cells. All right. And then there's the process of homeostasis and healing. Now, homeostasis is the tendency to resist change in order to maintain a stable, relatively constant internal environment. And homeostasis typically involves negative feedback loops that counteract changes of various properties from their target values, known as set points. And this is the incredible design by Hashem in our body. So you can start with a stimulus that changes the balance. It's usually detected by a receptor. And I think one of the sponsors, Ken Jacobson, because he's done tremendous work on receptor physiology. So check out his work, it's outstanding. That eventually is interpreted like a control center, often in the brain. Then there's an output to respond, an effector that the endocrine system comes in, and then you get back to balance again. So for example, if there is an opening of one of those cholulim, the blood vessel, a blood clot forms, but that blood clot can't stay there. It has to be eliminated. And so healthy wound healing requires receptors and negative feedback to make sure that cells come in, they grow, they repair, and then they stop. It's, I think, related. And just as an example from my own personal experience, I'm on my knees at a Hanukkah party. This was about 12 years ago. I unfortunately tore some ligaments in my left wrist, and so I had to wear a cast for 4 weeks. But because of the incredible design of our bodies, 4 weeks later, that cast came off. Oh, it was one of the best days of my life, and off my left wrist, and my wrist was essentially healed. So we have tremendous design in our bodies. And so now let's revisit, as we finish up, the opening questions. 1, the topology of the human body is most similar to what object? The torus. We are donuts. 2, how many cells are in the human body? Roughly 1 trillion. True or false? There are more bacterial cells than human cells in and on our bodies. True. How do you like that? True or false? To reduce the risk of allergies, one should avoid washing hands with soap and water before eating. False. Please, soap, water. If you can't get to that, then use hand sanitizer. It is very helpful for keeping yourself healthy. What is a fractal? It's not a type of Muppet. That's from Fraggle Rock, if anybody knows or cares about it. It's not a pterodactyl. It is a curved object that exists in between the classical Euclidean dimensions. And then finally, when added up, how long are the blood vessels in a person? 60,000 miles in our bodies. And so the final summary, our bodies comprise 30 trillion human cells and 40 trillion bacterial cells. And how do we keep that balance? 1 billion years of tradition, which is made possible by our topology of being toruses. And a properly constituted microbiome that lives in and on the torus is essential for normal life. Chalulim, the vasculature, is a marvelous example of well-designed hollows. Fractal design permits the function of the circulation, the brain, the lungs, and many more aspects of our bodies. Our openings must remain properly sealed. And the tubes and hollows, they have to remain open. Because if not, it's a problem. And thank God, we have homeostasis and healing, and we have repair and cell turnover. Our bodies are constantly doing teshuvah. And with that, I want to thank everybody for listening. I look forward to the next part of the discussion. Thank you.
Thank you so much, Aaron. That was fantastic. Our own Jewish edition of Fantastic Voyage, I think. The first question that comes to my mind, if I can have the privilege of asking the first one, is can you say a little bit more about what is the current theory of why there are so many more autoimmune conditions increasing in prevalence?
All right, so this is not my area of research, so I will step back and say I'm not an authority in this area. From what I've been able to see, there's first no good answer. Anybody who says I know what's going on and why it's happening, that's incorrect. I think the field is moving more toward there's a problem certainly with the microbiome, and that the proper one is not there. I remember listening to a lecture from an authority in this area at Mass General Hospital in Boston, and he said, what do you recommend to patients? We had a daughter at the time who had peanut allergies. He said, I don't know, get a dog. So it really isn't well known. I mean, the fact is that we're around dogs, and the microbiome and the dog interacting with our microbiome might be good. So we don't really know why, but great minds are working on what might be causes and therefore might be responses to it. What I showed so far is possibly part of the cause and probably part of the solution.
Thank you. Thank you. The next question I want to ask you is in your area of expertise, but the request is, can you use more simplified layperson language to explain a little more about what is a brown fat cell and how it connects to insulin resistance?
Yes, yes, I can. In our bodies, there are two types of cells that store fat as their main job. There's the white fat cell, and then there's the brown fat cell. There's about 20 to 30 pounds of white fat cells in our body, and the job is to store calories in a very efficient way chemically. So if you have white fat, someone who weighs, let's say, for example, 180 pounds, has maybe 30, 40 pounds of white fat on them, they can go weeks without ever eating again. And that was extremely important for periods of time when food was not as plentiful. As I mentioned, there's now 10s, 20s of pounds of white fat. Brown fat, there's a few grams of in the body. Brown fat stores fat not as a storage location so that the body can use it later for fuel. Brown fat stores fat to burn it up when we're cold. So you go outside right now, it's not particularly warm. Before you shiver, the brown fat is there and is turned on by the brain to generate heat. And it does something called non-shivering thermogenesis. In other words, you don't even feel your brown fat being on. I know my brown fat is on at certain times and I don't feel it. And brown fat is responsible, its main role is to take the fat that's stored in it and to burn it up as it's needed. Now, that's the structural role of white fat, is to store fat, and the brown fat is important for storing fuel to keep us warm. But they also have, and this is what my research relates to, they also have endocrine roles. They send messages. So for example, if a person doesn't have enough, like if a woman doesn't have enough white fat in her body, then the white fat is unable to send messages to the brain saying there's enough fuel, and that will stop menstrual cycles. The white fat is telling the brain there's enough fuel here to support a pregnancy. And if there's not enough, that's a problem. So for example, female athletes and people who have anorexia nervosa, or sometimes even bulimia nervosa, their menstrual cycles will stop because the white fat said, not safe. White fat also sends a message that there's not enough, the message to say you should eat more. And that's an area of looking at leptin research. It also increases insulin sensitivity. So that's called adiponectin. So white fat, its job is to store calories, and it communicates with the rest of the body. The brown fat, its job is to keep you warm. And based on the research that we're doing, when activated, it may also, just like the white fat, secrete some hormones that lead to increased insulin sensitivity, proper processing of lipoproteins, such as the LDL good and the LDL bad and the HDL good cholesterol. But these are early areas of research that we're working on.
Thank you. There's another question that I'm going to pass along, although I don't personally understand it. So I'll just read it. if taking protonics, what does one do in balancing the acids?
That is okay. So that is directly related to something I said. Is that protonics is a medication that reduces the production of stomach acid. So that's very useful for people. But protonics is prescribed a lot, and it can be overprescribed. And as I showed you, the reduction in stomach acid can lead to complications. I personally don't know what gastroenterologists or others do when a patient is taking protonics to make sure that the proper balance of bacteria remains in the gut microbiome. I don't know, and I could look it up and we could talk about it additionally, and hopefully gastroenterologists are getting a sense of it. But it was only, I mean, when I was a medical resident, everybody was on protonics. And I think it could have been helpful. But now we have to deal with the fact that we've altered the microbiome, and there are things that probably might be helpful in getting the microbiome balance back.
Thank you. Is protonics the same thing as PPIs?
Yes, protonics is one of the PPIs. I think it's omeprazole.
Right, okay. I just want to say, speaking for myself, this presentation was just beyond my hopes for how someone like you, who's a specialist in one particular thing and does research in such a particular area, that you're able to sort of, pull yourself back and look in such a broad way and give us so much enlightenment about everything about our bodies. I think we all would have to say, and I see it in the comments, we really can't thank you enough. Here's one more question. I assume that sponges are fractals, the animal sponges. Are sponges among the earliest such fractals? Are there any connections between them and vertebrates?
That is a great question. I don't know. I would say that the sponge, as like the animal that's a sponge, it may be one of the first examples of a Menger sponge kind of topology. I'm not sure. I'd have to study it. The notion of fractals being within in cells, I mean, mitochondria predate the sponges. So it's the notion of a fractal design has been in nature for longer than that. But I wonder, good question, is the animal that's the sponge one of the first examples of that kind of topological approach to existing as a multicellular organism? Great question.
Right. Amazing presentation. Thank you so much. Okay. From our previous speaker, Jeremy Schnittman, we're hearing the large-scale structure of galaxies in the universe is also fractal.
Yes, I saw that. Yes, it's at all scales of God's creation. Fractals, they're there.
Okay, and one more on the brown fat issue. How does dietary sugar relate to brown fat creation and A1C? And please tell us all what A1C is.
Oh boy. Okay, so let's start with we'll break it down. Dietary sugar, that's the sugar we eat. We eat multiple kinds of sugars. We eat sugar is a general category. So I assume we're talking about glucose and sucrose and fructose and maltose. Those are different ones. As far as we know, there's no obvious relationship between dietary sugar intake and the creation of brown fat. Brown fat is generated in response to cold exposure, that we know. And our group, that was part of the paper that I referenced in that graphical abstract. We showed that a medication taken at a higher dose than what's permitted, so don't do this at home yet, that could also lead to an increase in brown fat. In terms of the hemoglobin A1C, the hemoglobin A1C is a way that we measure the average blood sugar in the body. And it's particularly important for people with diabetes to get a sense of what their average blood sugars are. You can get a moment-to-moment blood sugar, but one's blood sugar in the morning when fasting could be 80, but after eating could be 160, or in diabetes could be 275. So the A1C gives us a nice 3-month average of what's going on. we know that the medication that we treated people with dropped the A1C slightly, and that's a good thing. If you want it, you can drop the A1C in a person who has diabetes. There's no direct connection that we've identified yet between brown fat activity and lowering the hemoglobin A1C. There might be connections, and we have ideas of how that could happen, but nothing has been established yet in that area.
And here's a COVID-related question. Can you shed any light on why it is that blood clots in the lungs are such a feature of COVID, and relate that to what you said about the circulatory system?
Yeah, and it's not just COVID, but that's a good example of it. For some reason, these viruses are triggering in a certain subset of people an immune response that's detrimental. And part of an immune response that's detrimental is having too much inflammation. I mean, these are concepts that are very detailed, and one could spend some time. I didn't prepare enough to go through it now, but I think the simple explanation is that in a large, too many people, unfortunately, having a COVID infection triggers the immune system and an unfortunate release of hormones within the blood that lead to more clotting than is considered necessary. And that leads to then the clotting within different blood vessels, and then clotting within different organs that those blood vessels are in. And that causes the kinds of problems we're seeing in people. I don't think anybody has a great sense of why it is that people who have, some people have COVID infections will get this hypercoagulable state. They'll have a lot of coagulation going on, whereas other people do not. One of the key drivers that has been seen in all studies throughout the world is age. We don't know why yet, but that's something that's very important, which is why everybody should, certainly above a certain age, should be able to get as many doses of the COVID vaccines as possible, because that really helps prevent these kinds of hypercoagulable problems from happening.
Thank you. Thank you very much. Okay. And do the vaccines also cause clots?
I mean, and I'm not going to get into the COVID vaccines. Yes, there can be clots. I don't know, but I suspect that the mechanism of the clot causing from the vaccines, given its very rare frequency, is from a different mechanism from the way that clots are being caused on a more common basis from the viral infection from COVID.
So you're saying that the clotting from COVID, the disease, is way, way more frequent, way more prevalent than clotting from vaccination?
Oh God, yes. I mean, it's orders of magnitude different. I don't know the full mechanism of one versus the other. Because the end common is clotting, there has to be some overlap into the pathways. But my understanding is that the genesis is different, although you do come eventually to some of the problems. But the frequency is much higher clotting in COVID than it is with the COVID vaccines.
Thank you. Thank you. Stuart, do you want to?
Yes, thank you all. Thank you, Rabbi, for being the host. Thank you, Judy, for the questions. Of course, thank you, Dr. Cypess, for the fantastic presentation. And thanks to all of you who came in and joined us and who asked very interesting questions. This will be recorded. You'll be able to see it again and tell your friends they can watch it on YouTube. Also, join us, please, on Sunday, May 8th at 10:30 in the morning for another wonderful presentation. Good night, everyone. Thank you.